12, determine if f and g are inverse functions. Alright, so this part's pretty important. So f and g are inverses if and only if, remember that from geometry, if and only if f of g of x equals x and g of f of x equals x. So when you plug in g of x into f of x and simplify, you're just left with an x. And the same thing if you plug in f of x into g of x, you should just be left with an x. So you do have to show both. Alright, so we're given the two functions f of x equals negative 3x plus 2. And then the function g of x equals negative 2x, negative 2 minus x divided by 3. So I need to find f of g of x. So we're going to plug that in. So f of, I'll plug all of this in for g of x, 2 minus x all over 3 equals, now I'm using this function f of x, negative 3, but instead of x, we're going to plug that entire g of x in, and we got a plus 2. So in place of this x, we're plugging in this function, 2 minus x, all divided by 3. Okay, and now we get to simplify this stuff on the right. So we're going to distribute. I've got a negative 3. We can multiply that. Think about it, it's just over 1, so I'd multiply the numerators, multiply the denominators. So negative 3 times 2 is negative 6. So I'm going to do this in a different color. Negative 3 times 2, negative 6. Negative 3 times negative x, positive 3x. All of that's divided by 1 times 3, which is 3. And we have a plus 2 out here. Alright, now I can simplify that. I'm dividing both of these things by 3. Negative 6 divided by 3 is a negative 2, plus 3 divided by 3 is a 1, so we're just left with x, plus 2. I have a minus 2 and a plus 2, which will give me 0. So the entire thing is just equal to x. Alright, so the f of g of x checked out. And now we're going to check g of f of x. I'm going to erase this for now. You should already have that written. Okay, so now I'm going to find g of f of x. And so this is g of, in place of f of x, I'm going to put this negative 3x plus 2. So I'm going to take that function, g of x, which is 2 minus x all over 3. But remember, in place of x, I'm now going to write the negative 3x plus 2. And now we're going to simplify everything on that right side. So here, I've got a negative that I need to distribute. So I'm basically multiplying this stuff by negative 1. So we have 2 minus a negative 3x, so plus 3x. And then negative times a positive 2 gives a negative 2. All over, we still have a 3 down there. Okay, now we'll simplify 2 and negative 2. When we combine those, we get 0. So we're left with 3x divided by x. 3x divided by 3. 3 divided by 3 is a 1, so we're just left with 1x, which is exactly what we wanted, so this one checks out. So the answer, yes, f and g are inverses because f of g of x equals x and g of f of x equals x. I would practice writing this out. It will help you remember what you're finding to decide if these things are inverses. All right, I'm going to let you do 13, 14, 15. You can actually do all of the rest on your own. Okay, and then lastly, we'll look at number 3 and 4 down here. So we're going to use composition to determine whether each pair of functions are inverses. Now the only thing that's different here is that we're given some domain restrictions. And that's really because it won't be a function if we end up having the positive and negative of our square root. So let's do number 3 together. I'm going to find g of f of x Alright, so I'm using green for g of x and blue. Oh, it's actually g of x and r of x. So let me change this to an r. Alright, so r of x is x squared plus 4. So we're finding g of x squared plus 4, so I'm going to take this function, square root of x minus 4, in place of that x though. Remember, I'm plugging in the r of x, x squared plus 4. Okay, now we get to simplify all that stuff, all this. So if I look inside those parentheses, I've got the square root of x squared plus 4. So I'd have to be able to take the square root of that, which I cannot. So we're stuck with the square root of x squared plus 4 minus 4. So the answer is no. G of x and r of x are not inverses.